In this slide deck, we're going to continue our conversation from a previous class about the increases in carbon dioxide and how it relates to global climate change. A big question we face is, what do higher CO2 levels mean for our future climate? As we saw last time, the historical record demonstrates that temperature tends to follow carbon dioxide levels in the atmosphere. So as CO2 increases, so does temperature. And we are seeing already a massive spike in carbon dioxide levels in our atmosphere. So what might the future hold in the coming years? In the past, we've called this global warming, sometimes climate change, more recently just climate change. And this becomes a feedback loop, for as CO2, one of the greenhouse gases, increases, so the temperature intensifies. And this loop continues to reinforce itself as it has over the millennia in previous eras. This slide overlaps the change in temperature on the vertical axis with time. And we do see a slight increase in the actual observed temperatures throughout the 19th and 20th centuries. The yellow bar is projected ranges. We do not know what the temperatures will do for sure. The atmosphere is an extremely complicated system over a very large volume. However, we are certain at any rate the trend will continue, with at least some increase since observed temperatures in the 1850s. Again, this is a very complicated model to predict, and this is a gross oversimplification of many of these models, yet it will help us understand where things may trend towards. Here we're looking at the average temperature throughout the 20th century. The gray line is the average for the whole century, and the green line is the observed temperatures. So we see overall a trend increasing. And remember, at this time also, CO2 levels, while not included in this graph, were also increasing. So if we set our average temperature as a 0 mark, we see at the beginning of the 20th century, in the 1900s, the temperature was about a half a degree colder than it averaged out to be over the course of the next 100 years. Currently, we're about a half degree over where that average was. And again, this question is, given the likelihood of the trend increasing upwards, how will this affect us? Again, this is a very complicated question with many computer models working on it, many extremely complicated. And given the parameters we work with, we get different results. However, the general consensus between many of these models over time, as we continue to improve them, is that we'll likely see an increase of anywhere from 2.5 degrees Fahrenheit to 10 degrees Fahrenheit over the next century. These are catastrophic shifts that happen in such a short time. In past history, these rapid shifts would take centuries, plural, if not millennia. We do not know of a time when we've seen this big of a change in this short of a time frame. When we talk about deep history, we're talking geologic time. This is rapid. The Earth does not normally change this fast in a sustained manner, except in the case of extreme events such as meteor impacts and volcano eruptions of massive scale, such as Mount Krakatoa. So what does it mean if we have an increase from 1.5 degrees Celsius to 5 degrees Celsius? A small change is a big difference. Again, this is another XKCD cartoon. What I love about XKCD is that he uses science to back all his data, all his images. They're not just fun. So a drop in 1 degree below the temperature in the average in the 20th century, we have an ice age. We don't know what will happen if we go up a degree. But we do know if we hit 2 degrees, we hit the same temperatures we saw last in the Cretaceous period when dinosaurs were roaming the Earth. This increases sea levels by 200 meters, which will decimate the majority of human populations. The glaciers will be gone, and we will see tropical plants to the poles, wiping out the temperate and polar regions and those ecosystems. Keep in mind, this is a projection based on the climate models, but we do know that these small fluctuations can cause huge differences. So the climate system, remember, is a very complicated set of feedback loops, beginning with solar energy and how much of it is absorbed into the atmosphere and how much of it is reflected back by the atmosphere itself, how much is reflected from the Earth, how much is absorbed by the Earth based on its surface use. Some surfaces absorb more heat than others. For example, forests absorb a lot of energy. However, blacktops and buildings reflect a lot of energy. We can see this in the fact that many cities are 1 or 2 degrees warmer than their surrounding environment. When we see the coupling all over here, that means is interactions. So the atmosphere-land coupling is heat energy moving from the atmosphere into the land and back out. Same thing in the atmosphere-ice coupling. We have heat exchanges going on between oceans, and the Great Lakes do this as well. So all this is showing we have a huge set of interactions. And this, of course, is oversimplified because we're only looking at a small part. But we do need to keep in mind that here, the changes in atmospheric composition caused by human behaviors cannot be ignored. We have released immense amounts of carbon into the atmosphere that was locked away millions of years ago by the ancient wetlands that used to dominate back in the Cretaceous and earlier periods. So we cannot think that these do not matter, for these are especially carbon dioxide is one of the major greenhouse gases. And we've been releasing it to a point that it is causing an observable trend and change. And as the CO2 concentration increases again, so too does the temperature. Another thing to notice that we'll look at briefly also, as the ocean changes its average temperature, this can change its salinity. That is, how much salt is in it, which then changes its pH, which can be a devastating problem to many life forms. Takeaway here is the climate system is a very complicated system. We're going to continue on from there. There are some changes. This winters likely will be a little warmer, so less, but the storms that do happen will be more severe. The weather bands will shift. This will allow for some increased food production if severe weather events do not disrupt them. Again, this allows some animal species and plants to move further north or further into higher altitudes. But again, this is all predicated on, that as we gain more warmer areas, we also increase severe storm events, we increase sea level rising, so there is a cost to all these potential benefits. So some possible consequences, we don't know what's going to happen. We can predict, but we do see some changes already. We see glaciers melting. We see areas of mountains that used to be huge ice sheets 60 years ago are now open lakes. The change in weather problems, the melting ice leading to higher sea levels. How this is going to force us to change our agriculture. This has already been observed by our farmers in the grain belt, where corn is now being grown more in the Dakotas, where it used to be grown more further south in Kansas and Nebraska. So we're already seeing shifts in our own food production as farmers further north realize they can grow longer season crops that they used to not be able to. This has huge effects on plants and animals based on where they live and their behaviors. And there's so many impacts. This kind of details them, and I encourage you to take some time to read through these on your own in the slides. You say this changing in our climate, especially at a rapid breakneck pace, is going to be a major problem. One example, trees are migrating north. Oaks and maples are producing less maple syrup for the southern parts of the region and more in the northern parts. Oak trees are seen not to be growing back in parts of Appalachia. They are only germinating in further northern latitudes. So the forests will change over the decades and centuries as these hardwood trees move further north. because it becomes too warm for their seeds to germinate in the southern parts of the region. We've seen the loss of glaciers. Cities may flood with rising sea levels. Florida will likely be flooded. We will lose the Everglades, one of the largest wetland ecosystems in the world, with only 5 meters of increased ocean. This includes the cities along the coast, all those beaches gone, and I think Disney World is in the impacted area as well. Some of the most densely populated areas in the world are threatened by this sea level rise, especially in South Asia and also along parts of China and on the eastern seaboard of the United States. This could lead to shifts in where and how organisms live, to change their migratory patterns, and also to change some of the hunting behavior, for example, of polar bears, which has been a major point of contention lately. We've seen impacts in the oceans with the bleaching of corals. There are some things we can do to reduce risks, increasing the efficiency of our cars, change how we clean our exhaust from fossil fuels, and how we gain our energy, shifting to renewable energy and relying less on individual car ownership, limiting urban sprawl. Again, check this slide out more another time. There are many things we can do individually, changing how we live, and these small habits can add up to a big difference. International agreements are trying to approach this problem. But these are difficult. Changing human behavior is extremely difficult, and there are powerful lobbies and companies who are pushing against this. But we need international agreements because the pollution in one country affects the pollution in another country. Climate change isn't limited by national borders. It is a global issue. And we have problems between developed countries as our own and developing countries, such as much of the global south, who want the wealth and security that they've seen in North and Western countries. One of the landmark agreements is called the Kyoto Protocol. Unfortunately, our country did not participate in ratifying this, but this laid the groundwork for what became the Paris Agreement, which the United States will be a part of for a few more months. This is a set of goals set to keep the global temperature change down 2 degrees. However, President Trump has chosen to withdraw the United States as of November 2020. All of the UN is a part of this agreement except for Iran, Turkey, and soon to be the United States. So there are global efforts to restrain the possibility impacts of global climate change. But all of this is a question. We don't know for sure what will happen. Our best science is warning us we must change our behaviors now or risk severe ecological damage and economic collapse. We looked at how greenhouse effect works. We described carbon dioxide, its importance in the atmosphere in keeping the earth warm enough for living things, but why it is troubling that its levels are rising. We also looked what a warmer world might look like.